So this is part 2 of the parent function notes. We just have a few graphs to finish with. Starting with f of x equals log of x. This is a common log. And if we go to our calculator over here and we go to the y equals function, we are going to type in log of x. So our log function is the fourth button up from the bottom on the left, log of x. And it's nice to look at the picture because we're going to draw the picture here in a minute. And it looks like this. But remember on the calculator, it kind of looks like the graph stops. But the graph doesn't really stop. It does continue going. Like one of the functions that we saw yesterday, it has an asymptote. I'm not going to get caught up in that, but there is a line here on the y-axis where we never touch the graph. And we can see that in our table here. Starting -2 has an error, and -1 has an error, and 0 has an error, but 1, 0, there is a good value that we can use to graph. But if we scroll through that screen, and I know that causes me trouble, but if you scroll, it's a lot easier at your desk. There's going to be another point in here that's a good point, easy to remember, which is 10, 1. So when we graph this, 1, 0, 10, 1, and it's going to look something like that. So once we get the picture there, then we can identify the domain. And that red dotted line there, it's kind of like a brick wall. We can't touch it and we can't break through it. So our domain on this function, we start at 0 and we continue on to infinity, but 0 is not part of it. We don't touch 0. We've got an error when x is 0. But our range can be negative. Our y values can be negative. Our y values can be positive. Our y value could be 0. Y can be anything. So our range is going to be all real numbers. If you remember from yesterday, even means symmetric with respect to the y-axis. Odd means symmetric with respect to the origin. And we don't have either one of those situations, so this is neither. And is the graph 1 to 1? Well, drawing any horizontal line on here will show us that we never touch the graph more than once. So there's our logarithmic function. As I flip over to the next one, again, the natural log, I just want to add that we put in an additional point, 8, 2.1. Thomas?
I actually have a question. So, since it doesn't exist, like the y values don't exist when x is 0, then why do you continue to graph down below?
So the next function, the hardest part about the next function is knowing how to type this into your calculator. And yesterday when we were doing the absolute value function, we were able to use the math button, which is what's going to happen on this problem as well. I'm going to start with the fact that we're going to go to y equals on our calculator. And then we're going to go to math. And number, like we did with the absolute value, but instead of number 1, which is the absolute value, there's another function on there, and I'm going to write that a little bit better, num. But then there's another function on there, and I need to look at it again. All of a sudden I Can't remember, but we're going to go to y equals. Let's clear that out. And then we're going to go to math and number. And it's going to be integer, number 5. int, number 5. And we're going to be graphing the greatest integer function here. Also sometimes called a floor function. And in fact, the way that I learned it is I learned it as a step function. It looks like a set of stair steps. And this is what I did for the quiz is I just drew the pictures on the calculator and then I screenshotted them into the quiz. So this is what it's going to look like if you happen to get a quiz that has this one on it. There's the stair step function. Before I get going too far, it's int, and I'm going to put number 5 here. For that, hopefully that makes sense, number 5. But when we draw the picture here, really what it actually looks like is it has an open circle at 1, and then it's got a solid dot here at 1, 1, and it's got an open circle here. So it's an open circle at 3, 2. We can go this direction as we saw on our steps. And the reason why I want to draw it more accurately, even though our calculator doesn't show it, is because if it is indeed a function, we have to pass the vertical line test. And an open circle means that that point is not actually on the graph. It's not included. Like we go from 0 to 1, 1's not included, but 0.99 is. That's part of that step. In terms of key points, what I wrote down here isn't what you see in your actual table, because your actual table just looks, well, let's look at it. Like 0, 0, 1, 1, 2, 2, 3, 3. But what happens is there's more than that. 0, 0, 0, there's 1, 1, there's 2, 2. It doesn't show the whole picture. So what happens is I said, well, 0, 0 was a point. But I also said that 1/2, 0 was a point. And if you look there in your graph, you can see it, even though we're not looking at it on the table. But we could. And then we've got 1, 1. But we also have, if I can draw it here, 1.5. 1 is also 1.5, 1. And there's more. There's lots of values in there. We could also have a negative point, like -1, -1. But there's also -1/2, -1. There's also a value on there. So just to give you a little bit of a perspective there, what's showing up on your default in your table function in the calculator, there is more to it. In terms of the domain, though, if we scrolled through our table, we wouldn't see any errors anywhere. The x value of this function can be anything. It's all real numbers. But our range is not. If you look at where our steps are of this greatest integer of this floor function, we've got a step at -2, at -1, at 0, at 1, at 2, at 3, at 4, 5. Our range are the integers. In terms of even, odd, or neither, remember even is symmetric with respect to the y-axis. Odd is symmetric with respect to the origin. And then there's neither. And it's not symmetric with respect to the y. It's not symmetric with respect to the origin. I don't think. As I stand up here now. No, it's definitely not symmetric with respect. It's neither. And then is it a 1-to-1? It fails the horizontal line test. If we draw a horizontal line, we touch and more than one spot here, so it also is not one-to-one. And in general, I'm pretty good with those functions. And actually, I've made it through this next one. There's a few functions that don't have names, which is the next one here. So that's when it's really helpful for me to start with the graphing calculator. And so we're going to go over here to our calculator. We don't have to type in anything special in here. We'll clear that out. We can use our fraction button if we have it. And it's 1 divided by x squared. And we look at the picture. So there is essentially what we're going to draw the picture of. Let's look at the table and see if we can get a couple of key points. But in terms of points, I didn't do anything really too fancy. I did -2, 1/4. Did -1, 1. And I know, how about the 0 error? I think I wrote that down on the front page. But in terms of points that I'm graphing, I'm probably going to graph -2, 1/4, -1, 1. +1, 1, +2, +1/4 in terms of points. So we've got -2, 1/4, and -1, 1. But the nice thing about being able to look at the calculator is we know in general what it's going to look like. We don't need a lot of points. We can see them on our calculator. And if you're really looking and thinking about the symmetry, you can get that one without too much trouble either, that branch. So we do have the error in the middle, which means that there is an asymptote right down the middle there at 0. And in terms of our domain there, we can never touch that value. So x doesn't equal 0. And then, again, what I like to ask for the range is, do we have a high point, do we have a low point on the graph? Well, we don't have a particular point, but in reality, even though I didn't draw my picture very well, all of our y values are above the x-axis. And when they're above the x-axis, we can say that we go from 0 to infinity, but 0 is not included. It's y is greater than 0. We're above. And to draw a picture, I said, if you're really paying attention on your screen, you see that if we fold this over, this branch will land on that branch, which means that we're going to be symmetric with respect to the y-axis, which means it's an even function. And then, is the function 1-to-1? No. We failed the horizontal line test. So, f of x equals 1 over 1 plus x squared. And let's type that one in. Again, if you don't have a fraction button for some reason, you need parentheses around the 1 plus x squared. But it's 1 over 1 plus x squared. And there's the picture. And I really only use 3 key points in there, but again, it's nice to have this picture to get some idea of values. But the three that I used are kind of right here in the middle. -1, 1/2, 0, 1, and 1 positive 1/2. In terms of our points. So, what did I say? -1, 1/2, 0, 1, and positive 1, 1/2. So, -1, 1/2, 0, 1, positive 1, 1/2. And I'll catch up with you in a moment. -1, 1/2. Didn't do me much good at all. So there's a picture. And once we get it drawn here, then what we want to determine is the domain and the range of this nameless function. But what we see, and if we don't see it from our drawing, if we go back and look at the picture on our graph, is that, now that I think about it here, that we don't move very much in this graph. There's only a little span for our range, but our domain is all rings. X can be positive, X can be negative, X can be 0. We don't have any errors on there. But in terms of our range here, as we look at the table, I'm going to look at the table just a little bit more. As we scroll through here, our fractions are getting pretty small. And then we've got 1. But again, our fractions are getting pretty small. Probably small enough that as we scroll through here, and you can scroll easier than I, what happens is, in this range, we're only going from 0, which is not part of the function, to 1, and 1 is. Clear? When it's included, you put a bracket. So this is, it's 0 is less than y is less than or equal to 1. 0 is not included. Again, it's so small that it looks like it's touching 0, but we keep getting smaller and smaller and smaller and smaller. We don't quite touch. In terms of symmetry, if we fold this graph along the y-axis, it looks like this side of the graph, the right side of the graph will land on the left, so it's going to be an even function. And is this function 1-to-1? Well, it fails the horizontal line test, so no. And one last function. So the square root of 1 minus x squared. So we're going to type it into our calculator. Y equals, and again, it's the square root of 1 minus x squared. And we look at the picture there. And there's not much to it. And we can look at the table, and we're not going to get much here. But as we scroll back, we can get 3 values, so we can come up with enough values to help us here. And what we have is, we have -1, 0. and we have 0, 1, and we have positive 1, 0. And it's going to be a tight squeeze on here. But negative 1, 0, 0, 1, 1, 0. Super tiny. Yep. So when we finish here with our domain and range, well, remember our domain, it goes from the farthest to the left of the graph to the farthest to the right to the graph. Well, the farthest to the left of the graph is negative 1. And it's on that graph. And it goes to positive 1. And that's also a point on the graph. Our smallest y value in this graph, because it's finite, is 0. And our biggest y value on the graph is 1. We go from 0 to 1. It's even. If we fold that graph in half, then the right side's going to land on the left side or vice versa. And is this function 1 to 1? No. We failed the horizontal line test.